Alright, so this problem here says determine what type of reflection was performed to the pre-image in order to result in the image. So for each problem, 1, 2, 3, and 4, we are given some coordinates before and after reflection happens. We need to analyze the coordinates of the pre-image and the coordinates of the image to look for a pattern. So we want to look for those patterns that we've discovered in order to figure out what line the pre-image was reflected over. So here, number 1, if we look, we have the point 3, 2. That is transformed by some form of reflection into the point 2, 3. Negative 1, 3 is transformed into 3, negative 1, and 1, 0 is transformed into 0, 1. So within those ordered pair x, y, we need to look for a pattern. And what you'll notice is that the numbers just flip the order they appear in. So here, 3, 2 turns into 2, 3. Negative 1, 3 turns into 3, negative 1. So the ordered pair xy turns into y, comma, x. And we know that when that happens, it means our points were reflected over the line y equals x. This is the rule that we follow every single time, we reflect over the line y equals x. All right, number 2, again, we want to figure out what happened, what type of reflection did the pre-image undergo to turn into the image. Remember, the pre-image would just be xy, and then x prime, y prime, that's the image. So here we want to look for a pattern. It looks like the coordinates, they flip the order that they appear, and they both turn into the opposite. So xy turns into the opposite of y, comma, the opposite of x. If you look, 4, 2 turns into negative 2, negative 4. It follows the pattern. Each coordinate here follows this pattern. And we know that that is the rule for reflecting over the line y equals negative x. And if you were to graph it on Desmos, you can see right here that the pre-image was in fact reflected over the line y equals negative x. Number 3, again, we're looking for a pattern that follows those rules that we've discovered. So here, the point 4, 2 turns into 4, negative 2. So it looks like our x coordinate for each of these 3 points stays the same, and our y coordinate turns into the opposite of whatever it was. So the ordered pair xy would turn into x and the opposite of y. Remember, we read that negative sign as the opposite of. So when we have this, we know that the points are reflected over the x-axis. And if you look at our picture here, you can tell that that triangle was in fact flipped over the x-axis. The x-axis is highlighted in green here. Remember, another word for a reflection is a flip. And finally, number 4, we need to look again for a pattern. So 4, 2 turns into negative 4, 2. So this time it looks like we're taking the opposite of the x coordinate, and then the y coordinate is staying the same. Let's see if that works for other points. Negative 2, 3 turns into 2, 3. Yes, we took the opposite of the x coordinate, the y coordinate stayed the same. 3, 0 turns into negative 3, 0. Yes, that follows our pattern. We took the opposite of the x coordinate, and the y coordinate stayed the same. So this means that our points were reflected over the y-axis. That is the rule for reflecting over the y-axis. Again, if you look at the graph from Desmos here, you can tell that we did in fact take that triangle and reflect it over the y-axis, which is highlighted in green.